Okay, so when we're working with radicals, so far we have looked at square roots. In this section, we're going to look at higher roots, specifically cube roots and fourth roots. And we're going to be just simplifying radicals with a higher index. When I say the word index, I'm talking about this number right here. If we have just the symbol and there is no index written, it assumes we're talking about square root and that our index is actually 2. But if it's a higher root, then we have to specify this is root 3, root 4. Okay, so kind of the tricky thing about these is they're a little bit less recognized. Your perfect squares, you probably learned your numbers squared at some point in your math career. But like cube roots, we may not know our cube roots very well. So if I'm kind of thinking through my cube roots, or my perfect cube, sorry, if I have 1 cubed, 1 times 1 times 1, that's 1. 2 cubed, 2 times 2 times 2, that's 8. 3 cubed, 3 times 3 times 3, 27. 4 cubed, 64. 5 cubed, 125, and honestly, that's about all that I recognize because they get really big really fast. For our fourth roots, I recognize even fewer of these. The fourth root, sorry, not fourth root, the 1 to the fourth power is 1. 2 to the fourth power is 16. 3 to the fourth power is 81. And honestly, those are the very few that I recognize. So these give you some examples here of kind of doing the inverse of that, taking the cube roots. And there is a cube root button on your calculator if you need it. So the cube root of 125 is 5. The fourth root of 81, we talked about that here, is 3. Fifth roots, we didn't get that far, but your calculator will get it for you. Fifth root of 32 is 2 because 2 times 2 times 2 times 2 times 2 gives me 32. And then some of the negative ones right here. We talked about with square roots that if we take the square root of a negative number, we get a non-real answer. Well, notice here, if I take the cube root of a negative number, I can do that. I get negative 4. And that's because if I take negative 4 times negative 4 times negative 4 or negative 4 cubed, I get a negative number. I get negative 64. But notice I cannot take the fourth root of a negative number or I get an undefined or non-real answer. And that's because this index is an even number. So that's kind of our rule here. If we have an even index, if we take the square root of a negative number, it's going to be undefined. It's going to be non-real. Okay, so again, we have kind of two methods to simplifying these kind of roots. Especially with higher powers, honestly, I would recommend using the factor tree method just because in general, we're not as good as recognizing perfect cubes and perfect fourths to help us simplify. But I'm going to do it both ways here. For the first one, I'm looking at my perfect cubes, the cube root of 54, and I'm looking which of these is a factor of 54. Well, 27 is, so I'm going to rewrite this as the cube root of 27 times 2. My rule that we used on our last section is I can rewrite this as the cube root of 27 times the cube root of 2. Well, we know the cube root of 27 is 3, and then we keep that cube root of 2. And just be careful writing this little index right here. Make sure it's a small number above that little tail so we don't think it's a number out in front. Okay, but I actually prefer on this one, on higher roots, to just use our factor tree method. If I'm doing the factor tree of 54, 2 and 27, 3 and 9, 3 and 3, if I write this out, I've got the cube root of 2 times 3 times 3 times 3. And because it's a cube root, I'm not looking for pairs this time. I'm looking for triples or groups of 3. Well, I've got one group of 3 there, so I'm going to bring a 3 to the outside. And I've got only a 2 left on the inside when I do that. So different method, same answer, whatever makes the most sense to you. Okay, on the fourth root, or sorry, 3 times the fourth root of 48. We listed a couple fourth roots here that hopefully we can, or perfect fourths that hopefully can help us. If I'm doing it this first way, the product property way, if I'm thinking of which perfect fourth will go into the square root of 4, or the fourth root of 48, man, I can use 16, and I can rewrite that as the fourth root of 16 times 3. I'm going to rewrite this one more time. The fourth root of 16 times the fourth root of 3. Well, above here, we know that the fourth root of 16 is 2, so I really have 3 times 2, which gives me 6, fourth root of 3. If we're doing this using our factor tree, 48. I'm going to do my factor tree. I get 2 and 24, 2 and 12, 2 and 6, 2 and 3. If I rewrite it using those prime numbers, I got 2, 2, 2, 2, 3. Since it's the fourth root, I'm looking for groups of 4. The fourth root of this means I'm going to bring that 2 to the outside. There's already a 3 there. 3 times 2 gives me 6. The only thing I have left on the inside of that fourth root is 3. So either way, 6 fourth root of 3. Okay, on example 386, I am not going to rewrite this out a bazillion times because x to the 25th would mean x times x times x times x 25 times, and we don't have time for that. If that's the only way you can do these, go for them. But notice here, I've got a 5th root. So I'm looking for groups of 5. So let's just kind of think logically. If I wrote out x 25 times, and I'm seeing how many groups of 5 that I can make with it, well, I can make 5 groups, and I don't have any left over. If we think about my y's, y to the 17th, if I think about how many groups of 5 I can make with that, I can make 3 groups of 5. 3 times 5 is 15, which means I've got 2 of them left over. And if I look at my z to the 3rd, well, I don't have enough to make a group of 5. I just have z times z times z. So I can't make any groups of 5, so I just keep that z to the 3rd on the inside. And then our last one here, pick whichever way makes the most sense to you. I'm just going to do the factor tree. If I am simplifying the 40, I've got 2 and 20, 2 and 10, 2 and 5. And if I want to rewrite this, I've got 2 cube root of 2 times 2 times 2. And then again, if it helps you, you can write this out. A to the 4th is a times a times a times a. B to the 8th is b, 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 b. We're looking for the cube root. Oops, I lost my 5 in here. I'm going to just put it in green there. So I'm looking for triples, or groups of 3. Got 3 2's right there. I'm going to bring it to the outside. 2 times 2 gives me 4 on the outside. I'm going to leave some space for my letters. If I'm looking for triples, I've got 1 triple of A and 1 little guy left over. Keep that 5, 1 little guy left over. B's, I've got a group of 3, a group of 3. So 2 groups of 3, and then 2 guys left over inside. So simplifying a higher root is very, very similar to simplifying square roots. If we're using the factor tree method, we're just looking for groups of 3 if it's a cube root, groups of 4 if it's a fourth root, groups of 5 if it's a fifth root, and so on.